This is the assessment practice for the topic 3 test. This is the first page. It's page 109 in your textbook. Let's get started with problem number 1. Krista arranged her buttons in an array. Which two expressions can be used to find the total number of buttons? Let's start by figuring out what the expression would be for this array. So first, count the number of groups. 1, 2, 3, 4, 5, 6. So the first factor in our equation is 6. Let's find the number in each group. 1, 2, 3, 4, 5, 6, 7. So the expression for this array is 6 times 7. Now let's look at our possibilities here and find the ones that will work. So the first one is 6 times 7 and 6 times 1. So what you should do is look at this and as a plus sign and think about the distributive property. That's really what this problem is asking you to do, is use the distributive property. So does it work? Does 6 times 7 equal 6 times 7 plus 6 times 1? No, it doesn't. The quick way that you can figure that out is, okay, sure, the 6 is a factor in both equations, and 6 is a factor in our original expression, but 7 and 1 are 8, not 7, right? 7 and 1 are 8. So that definitely is not going to work. That would be too big because this is really saying that those two expressions together are equal to 6 times 8. So that definitely doesn't work. So I'm going to delete that. I'm going to write here what our original expression is for this array and cross out A. All right, now let's look at B. 4 times 7 and 2 times 7. So does that work? Well, 4 and 2 are 6, and 7 is one of the factors. So just to write this out, like we've done in class, 6 times 7, is that equal to 4 times 7 plus 2 times 7? Yes, it is. So what they've done in B is they've broken apart the 6 into a 4 and a 2. All right, so B works. I'm going to circle it, but I'm also going to keep going so I can see if any of the others work, just in case. So what about 4 times 4 plus 2 times 3? Does that work? No. What we've been doing in class is that we always keep one of the factors the same. We can break apart one of the factors, but then we leave the other one the same. And none of these factors are 6, and none of them are 7. So I'm going to cross this one out. All right, the last one, D. Well, 7 is a factor in both expressions, and 7 is a factor in our original expression. But if I add 3 and 4, that would give me 7. So the original expression for these two expressions is 7 times 7. So that doesn't work at all. So the answer must be B, 4 times 7 and 2 times 7. Number 2, choose yes or no to tell if the distributive property is being used. Okay, a reminder. The distributive property says that a multiplication fact can be broken apart into the sum of two other multiplication facts. So we just did the problem number 1 had to do with the distributive property, and we've had lots of practice in class. So now what you're going to do is you're going to look at all of these equations and say whether or not the distributive property is being used. So is a multiplication fact broken apart into the sum of two other multiplication facts? So here is 2a, okay? 4 times 2 plus 3 equals 4 times 2 plus 4 times 3. Well, is one multiplication fact being broken apart into two other multiplication facts? Yes. Now, it might be a little bit difficult to tell because we are so used to, in the classroom, using parentheses. So if I add parens right here, sort of covered up one of the factors, but does that make it easier to see that the distributive property is being used? I hope so. The answer is yes. All right, 2b. 4 plus 5 times 2 equals 4 times 2 plus 5 times 2. Again, the distributive property says that the multiplication fact can be broken apart into the sum means adding together, of two other multiplication facts. So, do you see two other multiplication facts here? Yes, you do. Fantastic. So the answer there is yes. Now let's look at 2c. 2 times 4 equals 2 times 3 plus 1. Let's review again. The distributive property says that a multiplication fact can be broken apart into the sum of two other multiplication facts. Do you see two other multiplication facts here? No, you don't. You just see actually one multiplication fact right here. So the answer is no, not. Okay? All right, 2D. 7 times 5 minus 2 equals 7 times 5 minus 7 times 2. Now, I know that this looks pretty unfamiliar because we haven't used a lot of subtraction when we've been doing our multiplication and practicing the distributive property. But the question to ask yourself here is, has this first multiplication fact, 7 times 5 minus 2, been broken into two other multiplication facts? Yes. So the answer is yes. So the ones that can be where the distributive property is being used are 2a, 2b, and 2d. But in 2c, the answer is no, because that first multiplication fact, 2 times 4, has not been broken apart into two other multiplication facts. Number 3. Jeff makes the generalization that a tens fact can be broken into two fives facts. Write an equation to test his generalization. Okay, so your first step is think of any tens fact. Okay, so for example, I'm going to do, make sure my pen is on. I'm going to do 10 times 6. So 10 times 6. Now, can I break this into two fives facts? I think so, right? I could break apart the 10 into two fives. That's pretty easy. So then I would write 5 times 6 plus 5 times 6. Once again, I'm using the distributive property. So I'm going to add my parens here. And I'm going to say 10 times 6 equals 5 times 6 plus 5 times 6. So let's see. Can I write that in the little box? I can't. It's too small. Too small. I'll try anyways. Okay, so 10 times 6 equals 5 times 6 plus 5 times 6. And 5 times 6 is 30. And 5 times 6 is 30. And if I add 30 and 30, I come up with 60. So 30 plus 30 equals 60. Does 10 times 6 equal 60? Definitely. We know that, right? Because we know our tens facts, and we know that when you multiply 10 by any number, that digit goes into the ones place. So 10 times 6 is going to equal 60. So this right here proves that Jeff is correct. Number 4. June broke up a large array into a 3 by 4 array and a 5 by 4 array. What was the large array? Show your work. Okay, once again, this is all about the distributive property. So we have 3 times 4 plus 5 times 4. Okay, what factors did they keep the same? The 4, right? So we can put that right here. The question is, what goes there where the question mark is, the unknown? Well, I look at the first factor in both equations. I add it together, come up with 8. So 8 times 4. Does that make sense? It sure does. So if we have an 8, we can break the 8 apart into a 3 and a 5. So 8 times 4 would then equal 3 times 4 plus 5 times 4. So the original array is 8 times 4. All right. So when you're answering these, either on a separate piece of paper or in the box, I want to see all of your work. But the answer is 8 times 4 array. Number 5, which facts can you use to find 4 times 8? Select all that apply. So first, once again, we're talking about the distributive property. And when you look at these expressions, think of the and as the plus sign. So does it make sense that these two expressions together are equivalent to 4 times 8? And it might help to visualize this problem as well. So let's start by making an array that is 4 times 8. So start with 4 rows, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Squeeze that in there. Oh, that's not so good. Sorry about that. Okay, so in terms of my precision, I don't think I'm being very precise here, but I think you get the point. So we have a 4 by 8 array, right? 4 groups of 8. And let's just double check. 1, 2, 3, 4, correct. 1, 2, 3, 4, 5, 6, 7, 8. Okay, very good. Okay, I can move my toolbar a little bit. I am sorry that they're a bit messed up. Okay, so this is a 4 by 8 array. Let me write that up here. Now, the question is, when I look at these pairs of expressions together, are they equivalent to 4 times 8? So looking at the first one here, 2 times 8 and, or again, think of that as a plus sign, plus 2 times 9, is that equivalent to 4 times 8? Absolutely not. Okay, how can I tell? Well, if I were to split apart this array, so you have 2 groups of 8 and 2 groups of 9. Okay, so that would mean that I would draw a line here. So on this side, I now have 2 times 8. And on this side, I have 2 times 8. So could this first one be correct? 2 times 8 and 2 times 9? No, absolutely not. What if I didn't have this array here? How could I tell? Well, the 4 has been broken apart into two 2's. So that would be the same thing as 4 times 8 equals 2 times 8 plus 2 times 8. All right, so it's not this one for sure. What about the next one? 2 times 8 and 2 times 8? Yes, that totally works. In fact, we just did that one. So I can color that box in. All right, 2 times 4 and 1 times 8. No. Remember, we had a similar thing when we were looking at the solutions over here, or the possible solutions in problem number 1. When we're using the distributive property and breaking apart our multiplication facts, one of the factors has to stay the same. So none of the factors here have stayed the same, so I know that that is incorrect. Okay, what about 4 times 5 and 4 times 3? Does that work? Well, again, we've got 4 times 8. I see the factor 4 has been used in both expressions. And can 8 be broken up into 5 and 3? Yes, right? Because 5 plus 3 equals 8. So I know that that is a possibility. And if I wanted to visualize that, 4 times 5 and 4 times 3, let's see if I can very carefully erase. Oh, sort of. Okay. So if I wanted to visualize that, what would that look like? Let's see, I'll use a different color. Green. So 4 times 5 and 4 times 3. So 1, 2, 3, 4. 1, 2, 3, 4, 5. And I'm going to draw a line right here. So this expression on this side is 4 times 5. And this expression on this side is 4 times 3. Does that work? Yes, it totally works. Yay. So we're going to say that this one is also correct. Okay, finally, 3 times 8 and 1 times 8. Well, our original expression is 4 times 8. The 8 is a factor, so that part looks good. And if I combine the factors 3 and 1, I come up with 4. So that is equal to 4 times 8 as well. Okay, so this one, and this one are all possibilities. So that's the correct answer. And it's a big jumbly mess, but I think you get the point. Number 6, we're almost finished. This is a good, fun word problem. A bakery uses 3 cups of flour for each loaf of bread. There are 3 loaves of bread on a tray. There are 6 trays on a cart. How many cups of flour are used to make the bread on the cart? Show your work. All right. So step number 1 with any word problem is, what is the question that you are supposed to answer? You are supposed to answer, how many cups of flour are used to make the bread on the cart? So your answer, when you write it, should include cups of flour. So you are looking for how much flour will be used to make the bread on the cart. And a way that I would like to start solving this problem is by drawing a picture so that we can visualize what we are doing. So a bakery uses 3 cups of flour for each loaf of bread. So how can I represent that visually in a picture? First, I'm going to get out my drawing pen. I don't think I want green bread. Let's make blue bread. It'll be like made with blueberries. It'll be delicious. Okay, so here's my loaf of bread. Or my loaves of bread. Wait a second, wait a second. This is a square and it doesn't look like a loaf of bread at all. So let me just redraw that one. Okay, that's better. And they're a little bit closer in size. Wait a second. I'm sorry. Can I just start this one over? Okay, I'm going to delete my drawings. Okay. I got a little bit ahead of myself, so I apologize. So 3 cups of flour for each loaf of bread. All right, so let me start again. Thank you for your patience. So let's do my loaf of bread, and then how much flour do I need to make that? Well, I need 3 cups of flour. And there are 3 loaves of bread on a tray. So that's why I'd started to draw 3 loaves of bread, but I got a little bit ahead of myself. Okay. So inside, I'm going to write 3C period, and that's just an abbreviation for cups. Okay. So now this is my tray. Okay. Because it says that there's 3 loaves of bread on a tray. And now I see that there's 6 trays on a cart. So I'm going to run out of room. So I couldn't draw everything, but at least I can see here that I've got a tray and 3 loaves of bread, and each loaf of bread requires 3 cups. And then I also know, so if I drew the trays like this, right? 1, 2, 3, 4, 5, 6. Okay. Maybe I should have done it like this. Oh yeah, that would have been better, right? There's my loaves and there's that. Okay, so there's my tray, there's my 3 loaves of bread, and there are my 3 cups. But I don't really want to draw, I think, anymore. I think I can start using multiplication, but at least I've visualized the problem. So I've got 3 cups of flour for each loaf of bread, 3 loaves of bread on a tray, and 6 trays on a cart. How many cups of flour are used to make the bread on the cart? So I have to find out all the flour that's needed for all of the bread that's going to show up on my 6 trays. Okay, so first, what property am I going to be using? The associative property. Let me write that. The associative property of multiplication. The associative property of multiplication tells us that we can group factors in a multiplication equation and the product doesn't change. So first, just what are the factors in this equation? Well, the factors are 3 from the 3 cups of flour, another 3 from the 3 loaves of bread, and then finally 6 for the 6 trays that are going to be on the cart. And at this point, it doesn't matter how I decide to group these. The product is going to be the same. For me, I think it's easiest to group the 3 and the 3 together. So 3 times 3 times 6. Now I'm just trying to figure out what is 9 times 6. Well, I'll say I do know my 9's facts, and I know that 9 times 6 equals 54. So let me erase this big giant mess of drawings and write this a little bit neater for you. So in this box, I would want to see, or on another piece of paper, something that looked like this. 3 for the 3 cups of flour, another 3 for the number of loaves of bread on the tray, and then 6 for the number of trays that are on the cart. That is the same as 9 times 6. And 9 times 6 is equal to 54. So the answer would be 54 cups of flour. And that's important that you include the unit in your answer. You must include the unit in your answer. Yay, it's the last one. Okay, find the number that makes the equation correct. explain your reasoning. I know that you guys always love it when you have to explain your reasoning. But explain doesn't always mean words. It means that you could use numbers and symbols, but I really want to see your work. Okay, so 3 times 4 plus 3 times 4. Okay, here's how I'm going to explain my reasoning using numbers and symbols. I know that 3 times 4 equals 12. I know that 12 plus 12 equals 24. So I know that 24 makes that equation correct. See, explaining your reasoning in math doesn't always require words. Sometimes it does, but you can also use numbers and symbols. All right, owls, I do really hope that this was helpful. It was my first time trying to do a video where I explain all of these answers, so I hope I improve. But if you have any questions, just ask me in class.